Okay, we'll look at some of the homework problems that are in section 3-1. Like for these particular problems here, you ask for which of the following is it true that the number of elements in A plus the number of elements in B is equal to the number of elements of the union of A and B. Here's part A, where you have A with the elements A, B, C, and B with the elements C and E. And you want to find out if this is true for this. In this case, it would not. And here's why. This rule states that A and B must be disjoint. In other words, A and B cannot have any elements in common. If you look at set A and set B in part A, you'll see that C is the element that's in both A and C. So this would not work for this particular situation. So for part A, that statement would be false. Now let's look at part B. You got A with the elements A, B, C, and set B with the elements B and E. Again, that too will be false because now here B is common in both A and B. Again, for this rule to satisfy, A and B must be disjoint. So in this case, that statement will be false. Now I believe you'll be given a true false in the drop-down menu. And you just have to select which one is which. Now part C, we got A, which has the elements A, B, C, and now B is the empty set. Well, we have no elements in that set in B, and we do have A, B, and C. This would work because there's nothing in common in A and B. So this would be true. Okay. All right, let's look at number 2. Where it says here you want to determine if each of the following sets is closed under addition. And here in part A you got N, which is 0. And in this case here, we want to know if it's closed under addition. Well, 0 is the only element there in set N, so it has to be closed under addition. So that means it will be true. And by the way, for closed under addition, if you add any two numbers, that sum must be within that set for it to be closed under addition. If the sum is not in that set, then that means it's not going to be closed. Take a look at part B, where you have S has the element 0, 5, 10, 15, 20, and so on. Is that closed under addition? And in this case, it would be closed under addition because those 3 dots means that this set goes on and on and on. So any two numbers I add would fall in that set. Like if I add, let's say 5 and 10, that's 15. 15 is in that set. Or 10 and 20, that's 30. 30 is in that set because that set is an infinite set. So here, that answer is going to be true. All right, part C, where we got V, which is the set 5, 8, 10. Is that closed under addition? Well, let's say if I add 5 plus 8, I'm going to get 13. 13 is not an element in set V. So in this case here, that would be false. And then finally, the set of all x such that x is an element of the whole numbers and x is greater than 14. Would that be closed under addition? Okay, anything greater than 14, and it's a whole number like 14, 15, 16, and so on. Pretty much if I add any two numbers like 14 and 15, I'm going to get 29. That's in this particular set. So in this case, it'll be true. Okay, let's look at number 3, where we want to state the name of the property illustrated. Here we got 5 plus, and in parentheses you got 4 plus 8, and it's equal to 5 plus, and in parentheses you got 8 plus 4. And this expression is an example of which of the three properties here. Now let's look very carefully. The 5 is still on the outside. Look at the 4 and the 8, and look at the order of where the 4 and the 8 is. You got 4 plus 8 here in the bracket, and then on this other bracket on the right side, you got 8 plus 4. Here the order has changed. So this would mean I have the commutative property of addition. The commutative property of addition. Okay. Let's take a look at number 4. Here we want to use inductive reasoning to predict the next 3 terms in the pattern. Here we got 4, 7, 10, 13, 16, and so on. Let's predict the next 3 numbers in that pattern. Okay, that's pretty much similar to sequences that we talked about in chapter 2, I believe. Or chapter 1, I'm sorry. In this case here, we're adding 3 each time. So the next number after 16 will be 19. The next number after 19 comes 22. And the next number after 22 will have to be 25. So you add 3 to get the next number. Okay. Take a look at number 5. Let's say we want to determine if each of the sets is closed under addition, similar to one of the problems I did earlier. Let's start with part A, where L has the element 0. Is that closed under addition? Definitely, because there's only one element in that set. 0 plus itself is 0, so that's closed. Part B, where we have S is 0, 6, 12, 18, 24, and so on. Is that closed under addition? Well, add 12 and 18, you're going to get 30. That's in that set. Those 3 dots says it continues on and on and on. So, in this case here, that's true. Then next, N is equal to 6, 9, 11. Is that closed under addition? Let's add 9 and 11. That's 20. 20 is not in this set N. So, that's false. And then D, the set of all x such that x is the integers and x is greater than 9. And that's closed if it's closed under addition. Well, here that's 9, 10, 11, 12, and so on. Add any of these 2 numbers here, that would be in that set. So, in this case here, that would be true. Okay, let's look at the next problem, like number 6. Here's another set of problems that are closed under addition. And I'll pretty much quickly go over those. Part A, N is the set 0 closed under addition. That's true. This one is also true. This one, of course, is false. And this next one is true. Okay, look at number 7. Fill in the blank to make a true statement and identify the property of whole number addition that is illustrated. 3 plus 7 is equal to blank plus 3. Well, 3 plus 7 means that it has to be equal to 7 plus 3. Because 3 plus 7 will give you 10, so the right side has to give you 10 as well. So that means the missing number has to be 7. Well, notice that the order has changed. 3 plus 7 is the same answer as 7 plus 3. So that illustrates the commutative property of addition. And then let's look at this one. State the name of the property illustrated. We got 5 plus, and in the bracket, 3 plus 2, and that's equal to, in the parentheses, 5 plus 3 plus 2. In this particular case, notice that the grouping has changed. So that would mean that this is the associative property of addition, because the grouping of the 5 and the 3 and the 3 and the 2 has changed. Okay, number 9, use inductive reasoning to predict the next 3 terms in the pattern. In this case, we got 11, 14, 17, 20, and 23. And here we want to predict the next 3 numbers in that pattern. I'm seeing that we're adding 3 each time. So if we add 3 to the 23, you get 26. Add 3 to the 26, you get 29. Add 3 to the 29, you'll get 32. So in this case, 26, 29, and 32 are the next 3 numbers in that sequence. And finally, number 10, let's say we want to find the solution of 6 plus 2 is equal to 2 plus x. Here we're finding out what x is. Well, it's the commutative property, so if we have 6 plus 2, then the other one has to be 2 plus 6. So x in this case would be 6. Okay, this should be enough to assist you with some of the homework problems that are on the My Math Lab software.